Slides when you have a sec. So I'm gonna let Paul grill me for most of this time, but I thought I'd introduce with a few video clips to show you around the Zipline operation in Rwanda that's operating today, and kind of orient you guys to get started. So, you know, I love this photo to start. This is, I think there's no single photo that captures why we do this in Rwanda today than any other photo. Where the paved roads end, it's very hard to, if not impossible, to run a high reliability logistics operation. And in the medical world, not getting the medical supplies you need as a doctor to treat the patient in front of you can often result in death. And that's just why we do this. So let me give you a tour of our operations center in Rwanda. Starting here with a picture of our air traffic control tower. You'll see on the left, that's where we recover the planes, where they land. Under that tent in the middle, that's where all the fulfillment operation, inventory storage happens, as well as prepping and launching our zips. We call our little robotic aircraft zips, and on the right is where we launch from. So let me show you an order. So an order comes into our fulfillment operators, like any fulfillment center. And this is what it looks like to fill it. They grab a box, they then grab the blood required to fill the order, in this case 2 red blood cell units. They'll log that into our fulfillment system, wrap it in paper-based thermal insulation, and then they'll pass it out the window to our flight operators. Meanwhile, our flight operators have been getting the zip ready to make this delivery. They'll take that box, put it in a zip, they'll put it on a launcher, and then they'll launch it.
Launching Zipline 26 in 3, 2, 1, launch!
And now that zip is flying automatically out to the delivery site, where it will drop the package from the air into a little area on the ground we call the mailbox. And, oops, did I go too far? I went too far. Is it playing? There it goes. And so this is just a little cell phone video of a delivery recently. This is going in slow-mo so you can see it. The zip flies by. One little fun geek detail is that it adjusts for the wind speed and direction in real time to drop the package so it'll drift onto the ground where the customer actually wants it in that wind. And after that package is dropped, the zip will turn around and fly automatically back to our distribution center, and where it will land. We call that aircraft carrier meets bouncy castle. And as you'll see along the fence, our operation in Rwanda is also a spectator sport. Yeah, I love the way they talk about it. They call our zips, they call them sky ambulances. Actually, better than that, they don't call them like Zipline sky ambulances. They call them our sky ambulances, which we think is really promising for our expansion plans as we grow this service. A few other details, you know, a lot of what we do is the software and systems to be able to fly many planes in the air at once, dealing with all the regulatory requirements and all the, well, basically designing a system that can handle all the various weather and other things that can go wrong and still be operable by a very small team. So, you know, at any given time in Rwanda, we have a bunch of planes in the air, all making deliveries at the same time, operated by a crew of about 4 people. And that includes the fulfillment folks you see, as well as the flight operators that do all this. So this is a little, we stuck a GoPro video on the bottom of one of our delivery planes making a delivery. I just want to give you a sense of what we fly over. A lot of people assume that we fly, well, in the middle of nowhere. And I want to stress that that's definitely not the case. The hospitals we serve today, so we are responsible for 100% of the blood supply chain, blood product supply chain, to all the hospitals we serve in the western half of Rwanda. And each of those hospitals serves 500,000 people, person population. And it's important, obviously another big part of what we do is make the systems, again, all weather, no matter what goes wrong, still fly safely over populations like this. Let's see, I got a couple more. Well, this is my last little video clip. I love this video clip. It was taken a little bit ago, and we fly 12 hours a day, 7 days a week, and we'll go late into the night if we need to finish orders. And this is a zip coming back from delivering blood to a mother who had just given birth and was bleeding out to enable that doctor to save her life. All right, Paul, take it away.
Right. Well, I guess first, by way of introduction, I'm Paul Willard. Subtraction Capital is my venture capital fund. I think I'm the first airplane investor in Zipline. And not coincidentally, I designed aircraft for Boeing, including robot aircraft in the 1990s, which is why I've been introducing airplane companies to you all day today as well. Keenan, why don't you give a little bit about your background as well?
Sure. I come from the world. I started in medical devices and medical robotics. I started a project called ROS, the Robot Operating System, that's now taken off worldwide as sort of the Linux of robotics. I just enjoy kind of taking technology, figuring out a way to make it a brilliant customer experience. And that's just sort of what I geek out on.
So I guess a question just to get going. How did you choose this amazingly impactful market? Did you start there or evolve to it?
I mean, we evolved to it. Personally, I've been involved in a lot of projects that, really mattered, but we never figured out how to scale them. And lots of projects that, in my opinion, didn't matter very much, but we could scale them. And, we set out to really find something that really had both. And we heard anecdotally from doctors who work in remote areas in developing world countries that, hey, look, this supply chain problem really gets in the way of me doing my job as a doctor. They spent a lot of time traveling, ended up finding government partners very early before we've designed anything, first customers basically, and then we've been working with them for the last 3 years to really solve this problem.
And I know everybody at Zipline has spent time in Rwanda with your customers. What has inspired you the most as you've been there?
It's a good question. It's intense. It's very cool to see, these zips take off with blood in them and then come back without blood. And I've gotten to meet a few of the patients who have benefited, and I met a lot of the doctors, where their attitude at this point is just like, well, first of all, what's cool is we've only been doing this for, since end of last year, but already today, this is totally normal to them, which I think is so cool. It's just completely changed the way they think about interventions. They used to sort of think about any patient who comes to them as they're probably not going to have what they really need to treat the patient, but now they just order it, and we send it on demand, and they have it. And holding these units of blood in your hand, it's pretty crazy to think that a lot of those units you had to kind of guesstimate where to send them. You send them to a hospital, but they'd expire on the shelf because it's very hard to predict. Short life is very short. And now we have almost no waste in the blood supply chain, and that's huge for health impact.
A little bit about the planes, about the zips. So are they remote piloted at all, just to be clear? Do you buy them or build them? How far can they go? How fast do they go? That sort of.
Sure. So they fly about 100 kilometers an hour. We build them and design them. If you guys know of anybody who makes small robotic aircraft that have the fault tolerance and the weather robustness, let me know. But we couldn't find them, so we did it ourselves. And I missed the other. How far, how fast? Why do we make them?
Are they remote piloted?
They're not. They fly automatically. We have what we call a zip controller, so one person will kind of oversee all the planes in the air at once. And all they can really do is tell a plane, hold your position or come home, that kind of a thing. But other than that, the planes fly themselves. They deal with faults, any problems they have, whether they have, all on their own.
So what about faults? How fault tolerant are they? What kind of decisions can they make to save themselves if they find themselves in a fault?
Sure. They can basically deal with anything, any control surface failure, either propeller can fail, battery can fail. any cable connector, sensor, you name it. That's a lot of what we've built the last 3 years, is a system that actually can do that. And that's on the vehicle side. It can also deal with crazy weather, which is a big challenge. Most small drones in the world today, you don't fly them in the rain, let alone a storm. And dealing with planes, designing control systems that can fly a plane through a storm where the winds speed is higher than the plane can fly even. Those are big challenges to overcome, and a lot of where we spent our time. And
is that why you're using fixed-wing airplanes as opposed to the quadcopters that everybody else flying things around seems to be using?
Yeah, efficiency is huge. So fixed wing versus anything that can hover or quadcopter, you're talking somewhere between 5 and 20 times more efficient. That X factor is huge for getting the range and the payload capacity that makes this service practical. And then the other big wins of a fixed wing is it's much simpler to achieve those levels of fault tolerance and safety in that system.
And then why are you dropping the box remotely as opposed to hovering down or lowering a package like so many other people want to do?
It's really the only way. I think I don't know if anybody here has been around one of the big delivery drones. A lot of people, when they think about delivery drones, they picture the little DJI quadcopter, the kind of thing that you could, if you needed to, you could knock it out of the sky with your hand. The drones that make, they're just being designed for delivery, these big hover-capable drones, they're about, 3 meters across, some of them. It's basically small helicopters. And, you just don't want to be underneath them. You don't want them hovering over your house or your hospital to make a delivery. It's scary. And so for us, it's a pretty simple thing. Our delivery experience is, we think, very magical. Hopefully you guys get to experience it soon. Have a zip deliver to you. But it's very simple. It feels safe. It is much safer. And I just can't imagine that big hover-capable thing, the hovering giant drone over people's houses ever really happening.
And is this a venture-funded social enterprise, or is there a viable business that can actually come from this?
Yes. Yeah, no, absolutely. Like I mentioned, we operate these distribution centers with about 4 to 5 people on a shift. And right now they can do up to about 50 deliveries a day. Our next-gen system coming out this year is more like hundreds of deliveries a day, just with that small crew. So it's much more cost-effective way to make deliveries. It's very energy efficient. And yeah, part of the fun of where we are as a startup right now is, we have a concrete path to that sort of unit economics that we're driving to, and we're on our way.
And a last question, just to keep us all on schedule, I guess. How long will it be before everybody in the world has access to emergency medical supplies delivered to them, regardless of what country they happen to be born in?
We'd love it to be next year. It's a really interesting, we obviously have a big sort of engineering systems side of what we do and an operations side of what we do, because we sell a service. We don't sell drone technology or anything like that, which is what these healthcare systems want. But we're really excited. We think we can scale in a very meaningful way in the next 5 years, and hopefully be global scale, at least in developing world applications in the next 5-10 years.
Well, thanks for all that you do and taking the time, and thank you for listening as well.
Thanks, guys.